Hello and a good morning or a good afternoon, and welcome to our webinar today. Today we will be talking about the Fronius GEN24, which is a uniquely built, tested and trusted hybrid inverter from Fronius. And for this webinar, I'm joined by my colleague, Cyprian Okolo. He's our technical sales advisor for the Western African region, based in Lagos, Nigeria. And myself, David Mwangi, the technical sales advisor for the Eastern African region. I'm based in Nairobi, Kenya. So we do have quite a number of topics we would like to discuss with you today and to help you to understand why the Gen24 hybrid inverter is a very good fit for the African market. So we will take you through the introduction of the Gen24 Plus series, then we will look at the energy storage inspection, and later on look at the PV point, full backup, both in single and three-phase, energy management solutions. Then we look at how you can integrate additional storage of energy through heating water using the OnPilot. Then we also discuss the possibility to do AC coupling or retrofitting of the Gen24 to existing PV installations. Then we'll look at commissioning of the Gen24 Plus inverters. Then we also give you some information about the life cycle assessment of the Gen24 Plus inverters and the impact it has of the operating lifespan. Then we will also do a SolarWeb live demo of an active Gen24 Plus system with battery storage. So as usual, if you do have any questions during the course of this webinar, please feel free to post them in the questions area, and we will do our best to answer all your questions as we go along. So let's get started and look at an introduction to the series Gen24 Plus inverters. And these inverters are available in two key variations. So we have the single phase and the three-phase Gen24 Plus inverters. So the single phase are what we are referring to here as the Primo Gen24 Plus, and the three-phase are the Simo Gen24 Plus. In terms of the power classes, we have the power class 3.0 up to 6.0 for the Primo Gen24 or the single phase inverter. And then you have the power class 3.0 up to 10 kilowatts for the three-phase Gen24 Plus inverter. Both the inverters, whether single or three-phase, have two MPPTs for connection of PV power, and then they additionally have one battery output or input for connecting to the storage system. And the other variation that is available for the Simo Gen24 Plus are the inverter power classes from 3 to 5.0 kilowatt. So they do also have two MPPTs, one battery input, but they have a slight variation with the power class 6.0 up to 10 kilowatt. So as you can see, the smaller Simo Gen24 Plus inverters are available in 3, 4, and 5 kilowatts. But in terms of the comparison between now the smaller power class up to 5 kilowatts and the bigger power class 6 to 10 kilowatts, we can see that we have some slight variations, like in terms of the MPPT connection. We can do up to 12.5 on either MPPT on the smaller power classes, but you can do a connection of up to 25 amps for the bigger MPPT, MPPT1, and 12.5 amps for the second MPPT. The other variation is in terms of the battery connection. So we can see that for the smaller power class Simo Gen24, we can connect up to 12.5 amps, but for the bigger Gen24 Plus inverters, 6 to 10 kilowatt, we can connect up to 22 amps. So the effect that has on the backup options of the two variations is that for the smaller power class up to 5 kilowatts, you do not get full backup out of this inverter, but the PV point is still operational. But for the bigger inverter, 6 to 10 kilowatt Simo Gen24, you get both the full backup application or possibility and the PV point out of that inverter. So to give you a better understanding of why this Gen24 Plus inverter is a very unique inverter, I would like to now take you through the several awards that the Gen24 Plus inverters have won over the last couple of years. So in terms of the awards, we have quite a number for both the Primo and the Simo Gen24 Plus inverters. So starting in 2019, when the inverters won the REDOT award in 2019. In 2019, still the Plus X awards for high quality. In 2020, they are awarded by the Intersolar, and then the German Design Award in 2021. We are also very happy to announce that in the last 3 years as well, 2020, 2021, and 2022, the Gen24 Plus inverters have emerged first place in the Energy Storage Inspection Awards. So these are done by independent test labs, as we're going to see later. So out of this, for instance, the Energy Storage Inspection Award, I can take you also through briefly what this means for the Gen24 Plus inverters. So here we can see a comparison or a test that was done and compared quite a number of inverters, hybrid inverters, paired together with BYD battery box HV, depending on the connection. And we can see all the manufacturers here that were tested. So out of all the manufacturers that were tested for hybrid inverters, the Fronius Gen24 Plus with BYD battery box HV 11.5 kilowatt emerged first position with a rating of A as efficiency class. And this means that the considered energy overall efficiency was about 94%, and therefore this gave the best value of all times. So all the inverters tested before that had not achieved this kind of a figure, but the Gen24 Plus inverter was able to surpass any figures that had been tested before that. In terms of the implication of that on the system yield, so that allows the Gen24 Plus inverters to guarantee you maximum yield, and also that means highest self-consumption because you have integrated a storage system. In terms of the use of energy with the battery storage, that also means in addition that you are going to have the fastest ROI or return on investment for the PV system that you have used together with the Gen24 Plus inverter. To understand better the energy class or the efficiency class, so as we can see that the Gen24 Plus inverter achieved energy class or efficiency class A, and this means that for a system that is about 10 kilowatt peak, something that is above or equal to 93.5% is considered energy efficiency class A. And for a system that is about 5 kilowatt peak, anything that is above 92% or equal to 92% is considered as efficiency class A. And then we can see the other classes from B to G, what are the percentages that are achieved for those considerations. And therefore, the efficiency class for the Gen24 Plus and the BYD is what allowed the Gen24 Plus inverter over the last 3 years to emerge #1 in the Energy Storage Inspection Awards. So we can also look at the System Performance Index and what the implication of the System Performance Index is on the return on investment. So the System Performance Index becomes a core economic parameter. So just to give you an example of how this System Performance Index is calculated, we have the first image here, whereby we have no PV system installed, and this customer is paying an average 1,500 euros per year on electricity or energy costs. And then we have what we refer here as an ideal system, whereby once you install a PV system with storage, you envision that the customer is going to save about 1,200 euros per year, and therefore spending only about 300 euros per year from the grid or buying other energy sources. But in actual sense, the real system, the customer is able to save, as an example, 1,100 euros per year, but the cost of bought energy or power comes to about 400 euros per year. So what this means is, to calculate the system performance index, we are going then to consider the ideal cost savings divided by the real cost savings. So this is what is generating for us the system performance index. But in terms of also understanding this system performance index, we have to look at what or which losses affect the SPI. And we have quite a number of losses that can affect the SPI in a positive or a negative way. And we have the sizing losses, we have the conversion losses, we have control losses, as well as standby losses. So if you look at, for instance, the control losses, we are talking about the reaction time and the switching on of roads. And then in terms of sizing losses, we are talking about low discharge current and the impact it has on household loads. And then standby losses, as we all know, all electronic devices, when they are not in operation, they are consuming a bit of power for standby operation. And then you are also considering the conversion losses. So this is the limitation of efficiency and generation of heat as the inverter or the electronic component is working to convert power from one either DC or to AC, or from AC to DC, in this case for charging the batteries. Then you also have energy management losses, whereby in some countries you could be limited to how much you are able to export to the grid if this is allowed. And we have an example, for instance, in Germany, whereby in some situations you are only allowed to export maximum 70% of your installed capacity. So therefore, you could have a situation whereby you are losing quite a bit of energy if this extra energy or excess energy is not intelligently managed. So having a further look at the losses that are affecting the SPI, so we can see here we have a further classification of the efficiency starting from grade G1 up to I1. And we can see a clear correlation here between especially the conversion losses, which are the biggest contributing factor here. So we can see a clear correlation to when we have high conversion losses, then we have a very low system performance index. So on this end, we have for class G1, which is the rating for the Fronius GEN24 Plus inverters and the BYD battery storage. We have very low conversion losses and all the other losses to put together. And therefore, this allows the GEN24 to have a very high system performance index. So just about 94% as an overall for the system. So we can also talk about the losses. As we can see here, the conversion losses contribute significantly to what the system performance index will be. And therefore, we can also narrow down to where these losses can occur as far as conversion pathways are concerned. So in this case, we are talking about when you're converting your PV to AC power, and therefore this comes from the PV array to the loads, or especially to the loads, that is converted directly by the inverter. And then you're talking about conversion from the PV side to the battery side, and this is for charging. We're also looking at power coming from the AC side, that is the grid, to the battery for charging, and then power from the battery to AC. This could be for supplying both the loads or exporting to the grid if this is allowed. So if we look at the class G1, we can see that we have very high efficiency all through. So we are starting from 97.6 for PV to AC, and then 98.2% for PV to battery. For AC to battery, we have 96.9, and for battery to AC, we have 97.3. And therefore, this is what allowed GEN24 Plus inverters, in combination with the BYD batteries, to obtain first position after consideration of all these efficiencies. So the Gen24 Plus inverter, we cannot complete discussing it without looking at the unique features that allow this inverter to be a special inverter and outstart in the market. So in terms of the energy flow, we have a key concept that is inbuilt in the Gen24 Plus inverters, and this is the concept that we refer to as the multi-flow concept. The multi-flow concept, in a nutshell, relates to the possibility to have parallel energy flows. So as we can see in this illustration, we have the possibility to get energy from the PV side and from the battery side, or from the grid side, and all this can be combined internally by the Gen24 Plus inverter to supply your loads. So the energy multi-flow concept therefore allows the AC and DC coupling of the Gen24 Plus inverters. You can easily integrate, as a result, therefore, the Gen24 Plus inverters into existing PV installations, and this allows optimal utilization of the generated energy, and consequently that leads to higher profitability. So this is a concept that is embedded or integrated as a standard in all Gen24 Plus inverters. So looking further at the possibility to retrofit the Gen24 Plus inverter into existing setups due to the multi-flow concept, we have a starting point whereby you could start with a Gen24 Plus inverter with a complete system. So that means with its own PV array and a battery storage, and therefore you are able to take power from the PV side to charge the batteries. Then you can supply power from the batteries to your loads, or to export to the grid if this is allowable. In addition, due to multi-flow, the Gen24 Plus inverter is able to take a balance of power from the grid and recharge your batteries. If this is something that you'd like to configure your system to be able to do, this is possible. But in addition to that, if you have an existing PV installation, maybe with Fronius Snap inverters, and you have done your analysis in SolarWeb and have realized that there is quite a bit of unused energy in the setup, then you can bring in a Gen24 Plus inverter with battery storage, and this can be connected to, let's say, critical loads that can be powered even in the case of a power cut. So therefore, the Gen24 inverter is something that is very special to use, and therefore it doesn't necessarily need its own PV array to be connected or to be configured in an existing PV installation. So it's going to be sort of an AC couple installation, and it's going to utilize all the power that is coming from the existing inverter in the setup. Another key and unique feature of the Gen24 Plus inverters, which is also true for the Fronius Snap inverters as well as the Tauros, is the active cooling concept. With the Gen24 Plus inverter, we have a prominently placed cooling fan on the front of the inverter, and you can see the dissipation of heat happening all around the inverter through these cooling fins. So this fan would be just below the front cover. So normally you do not see these fins, but once you take out the front cover, then you're able to access the inverter. So having active cooling therefore means that the Gen24 Plus inverters can serve you in the market for a very long time. And also that means that in case of high ambient temperatures that the Gen24 Plus inverters can encounter, you have lower derating of power or later derating of power, because the inverter is able to cool itself sufficiently. So in a nutshell, that means that you have more yield and you are going to have faster amortization or return on investment from your PV installation. In addition, we also have the Superflex capability or design in the Gen24 Plus inverter. And that means that, as I had mentioned before, all the Gen24 Plus inverters have 2 MPPTs inbuilt. So that makes east-west design or south-west installation of PV arrays very possible. It could be symmetrical or asymmetrical, depending on the exact roof quotations that you encounter. And this Superflex design is also done or implemented with a broad DC input range. So we can see, for instance, for the SIMO Gen24 Plus inverters, these are the three-phase inverters. You can start from 80 to 1000 volts DC. And for the Primo Gen24 Plus inverters, you can start from 65 volts to 600 volts DC. So that means that you can start your PV string with only 3 modules upwards. So for each of the MPPTs. The Gen24 Plus inverters are also unique in the fact that you can get maximum charging and discharging power out of the inverter. In this case, we have a battery input or output of about 22 amps and charging and discharging power capacity up to 9 kilowatts for the bigger inverter. So this means that you have efficient use of the battery also during a grid outage, because the inverter is able to take the maximum current or power available from the battery, and therefore this will also significantly increase the self-consumption rates of the Gen24 Plus inverters. Another unique feature that is embedded within the Gen24 Plus inverter is the PV point. So the PV point, in a nutshell, is a connection for backup power that you can use even without a battery storage. So it provides you with maximum 3 kilowatt of power in single phase. The installation process is very simple, so you do not need to do isolation. And then the switchover, once there is a power cut, is automatic. And of course, like I said, you do not need to pay any extra, let's say, fees to have the PV point activated within the Gen24 Plus inverter. So it comes as already an embedded feature for all the Gen24 Plus inverters. So in terms of the power that you can get out of the PV point, as I said, 3 kilowatts. For starting purposes, you can get a maximum of 4.1 kilowatts for about 5 seconds, and this would allow things like motors to be started. And when there is a power cut, the PV point is supplied with the backup power in less than 60 seconds, and it has a non-exit in the inverter. So as I said before, you do not need to do any additional installation like grid separation, and therefore this backup box or backup panel is not required when you're configuring the PV point. So in terms of the operation of the PV point, it works like this. So if you have a grid outage, then the inverter is able to activate the PV point, and then all the loads that are connected to the PV point are supplied with the PV power directly, of course, after going through the inverter. And at the same time, if you have a battery connected to the Gen24 Plus inverter, you can have power going to the PV point, and then the balance of power can still be used for recharging the connected battery. In addition to that, the battery can also support the PV point. So the PV point can work with or without a battery connection. So, and that is where you also get a lot of flexibility with the Gen24 Plus inverters. So we can also look at the full backup capability of the Gen24 Plus inverter, which is critical here. And this will give you now maximum independence during a grid outage, because you can get a real three-phase and as well as single-phase power backup. In most cases, most other inverter manufacturers, even when they are three-phase, once there is a power cut, you only get full backup on one single phase only. But with the Gen24 Plus inverter, you can get full backup in all the three phases. And therefore, this means that you are able to supply the entire household or business where the inverter is connected. And therefore, this means that you can get energy independence. So for this reason, you do require a battery storage. So unlike the PV point, you can only get full backup in single and three phase if a battery is connected to the Gen24 Plus inverter. As far as the battery compatibility is concerned, the Gen24 Plus inverters are only currently compatible with BYD batteries. So we have what we refer to as the HVS and the HVM batteries from BYD. And then you can see for each series of the HVM or HVS, which of those are compatible to either the Primo Gen24 Plus or the Simo Gen24 Plus. So it's very, very important that when you do design a system for Gen24 with BYD, that you check this compatibility matrix to make sure that you have selected the right battery for the right Gen24 Plus inverter. So in terms of the backup operation, the way it works is quite straightforward, but you do need to configure a backup panel, because this backup panel, once there is a grid cut, this backup panel opens and closes some contacts, and a signal is sent to the Gen24 Plus inverter, and that signal is the one that allows now the Gen24 Plus inverter to go into backup operation mode. So for that purpose, you also do need a Fronius smart meter. So you are not able to configure full backup operation of the Gen24 Plus inverter without a Fronius smart meter. So there is a communication that is required also from the Gen24 to the smart meter, as well as from the backup panel, for the Gen24 Plus inverters to be able to go into full backup operation. So, and basically that brings us to the end of the first part of this webinar. So I'll now be handing over to my colleague Cyprian to continue with the remaining bit of it. So Cyprian, if you can join from here.
Yes, indeed, David. Thank you very much for a wonderful presentation. So I want to believe that we can all see my screen and then hear me clearly, as I will be taking over from this particular point onward. Yes, so we shall be continuing with, of course, still talking about the Gen24 Plus inverter, and then the various aspects, how it can be used. So we will be delving into the energy management solutions that can be obtained using the Gen24 Plus inverter. So starting off with the energy flow management, as earlier said. So this basically entails the consumption and, of course, production analysis of energy. And then after this analysis, of course, our system has to have the capability, which of course the Gen24 Plus has, to intelligently manage this energy flow to power loads, of course. And then afterwards, also has the capability of storing this energy either in the form of stored energy in the battery for later use, or as a matter of fact, storing hot water for later use. So we shall be shedding more light on this eventually in the next slides. Good. So still talking about the energy management, this can actually be achieved by the use of the 4 digital input-output ports that are already integrated in the Gen24 Plus inverter. This can, of course, in turn be used for various applications, which includes EV charging, of course, preparation of hot water, by, of course, using the home pilot, as I said earlier, we'll be shedding more light on eventually. And then, of course, operating a pool pump. And then for hot regions, we can also use it to control heavy loads that can be used for cooling, like the air conditioners. So, like I said earlier, this input-output ports are actually located on the digital input-output terminals of the pilot. The pilot is the designated data communication interface, or card, of the Gen24 Plus inverter. So as you can see, as indicated by this arrow, that is where we have the 4 digital input-output ports designated as IO0 to IO3, as can be seen. So these ports tend to generate or give out a 12 volts signal, and then these 12 volts are in turn used to control devices that are connected, of course, via external relays. This is exactly how it looks like. To put it in perspective, we have basically a wiring diagram of how this can be achieved. So with the use of the input-output ports, of course, these are actually pre-configured in the web user interface of the Gen24 Plus. So once this is done, for a particularly set condition, per se, which we'll also look into in the coming slides. Once these conditions are met, 12-volt signal will be generated on the ports, on the pre-configured port. So this now energizes the external relay, and then the contact of this external relay is now used to energize the appliance that we want to energize. Of course, doing this in a smart way, and of course, making use of the surplus energy generated from the PV. Of course, you can also have a manual switch to effect a manual override of this particular external relay. So, taking a look at how this comes into play economically, we have a scenario here where we have a PV consumer that comes home from work. So in this case, without an intelligent energy flow management control, so this person comes home from work at about 4 p.m. as can be seen, 16 hours, and then plugs in his EV for charging. So we can see that in most cases, this period is what is usually known as a peak period. And the peak periods actually come with a very, very high tariff compared to the other periods of the day. So this consumer ends up paying very high tariff values for this particular charging period. Now, let's now juxtapose it with another scenario where we have this other user that comes in and then makes use of the energy flow management digital input output ports to manage his energy flow. And then, as you can see in this case, not only does he avoids the peak periods, he also makes use of the PV intelligently to charge his or her EV, and then just pays a very, very fractional value, as you can see in this place outside the PV production curve for charging. So this in turn helps this particular user to save a lot of energy, and of course a lot of money in terms of the energy tariff being charged by the grid operators. So shedding more light on how this can be achieved, like I mentioned, so this is basically a mobile version of the web user interface. So this shows how you can select any of the input output ports you want to configure, and then go ahead to configure it. So this is, of course, here gives you the opportunity to select any of the input output ports, and then you can see them as drop downs. So you can, of course, go ahead and label them or name them as you would want to, and then, of course, configure it. So in terms of the configuration, you'd have to select how you would want to intelligently manage the load of the energy. So either by power production or by power surplus. So in the most economical fashion, option to take is by surplus, because we are, of course, looking at making adequate use of the surplus energy generated by the PV. So in this case, we would now look at the thresholds. So there has to be a threshold for coming on and for going off. So for coming on, I would have to set a threshold. In this case, the example here stated is 1.5 kilowatts. So this means that once the PV, the feed-in value gets to 1.5 kilowatts, it now automatically turns on whatever appliance that has been configured to the given input output port. Okay, so, and then the off condition is when the consumption from the primary loads gets to 1000 watts, for example. So this serves as the turn off signal. Shedding more light on this is this slide. So for this slide, it also gives us the various other ways that we can actually implement this. So we have the activation thresholds, both for coming on and for going up. So for this particular screenshot, we have it set at 2,000 and 500 respectively. And then another interesting way that we can actually make use of this is to configure it in terms of timing. So this means that we can have it set at a minimum and maximum duration of operation per day. This comes in very, very handy in terms of operation of a pool pump, for example. So we can set it to the maximum operation duration per day, say 60 minutes. So this means that once the condition is reached, we can have the pool pump triggered and it would now operate for 1 hour and then goes off. So this comes in very, very handy even when you're not at home. Once this is already set, you can be rest assured that the Gen24 Plus inverter would handle this operation. Another way to have it is, of course, this comes in also in a very unique way to charge your vehicle, especially during the nighttime, making use of the lowest tariff charge. And then, of course, it can be set to 360 minutes, which is 6 hours, to help you charge your EV in the most economical mode. Good. So yeah, so this can actually be achieved in a very, very smart way. And then, of course, depending on your preference, you can, of course, prioritize your energy flow. So what are we saying in this case? So we're saying that you can, of course, prioritize how your energy flows, depending on what device or mode of operation that you would prefer. So starting off with the first priority for this particular example, we have put the battery storage as our first priority. So this means that once we have surplus power, the inverter has, for this case, been pre-configured to give highest priority to the battery. So for every, the first point of call for channeling of surplus power will be to the battery, as can be seen. Then, once the battery, once the surplus energy supersedes the charging power, it would now channel the rest to, say, the home pilot for generation of hot water. And then eventually, if the battery is full in the process, it will now channel the whole surplus power to be used by the home pilot. And then once both storages, that is both the battery and then the hot water, has achieved its target temperature per se, it will now go ahead to activate other additional loads with the use of digital input and output. And then, of course, if you're allowed to feed into the grid, you can, of course, go ahead and then feed into the grid. Good. So as you can see, and of course, with this screenshot, we can see that the priority levels are battery takes the highest priority, then the home pilot, and then the load management input output ports. And then this is not to say that it's cast on clay per se. You can actually alternate these priorities. So you can have the home pilot as your highest priority, and then the battery as your medium priority, as you can see. So it's a very, very flexible energy flow consumption regime that allows you to prioritize it with regards to what energy flow channel you would prefer to have your surplus energy channel to. Good. So going forward, we now have a practical example. We have two of them. So let's go ahead with this just to show us how this can be done. So we have a particular scenario where we have a PV production starting at 7 a.m. per se. And then this, of course, kicks in by charging the battery, as you can see with the region shaded yellow. So the battery starts charging. And then when the feeding power gets to 1 kilowatt, the 1 kilowatt is actually the threshold voltage or signal point or turn-on point for the pool pump. So the pool pump begins to operate from 1 kilowatt and then stays on from, say, 8 a.m. to 11 a.m. That's about 3 hours. So once the pool pump has finished its cycle of operation, it turns off at this point. And then if you look further, the battery continues to charge until it gets to its full state of charge. Once that is achieved, the home pilot kicks in by generating or generation of hot power, hot water, beg your pardon. So this now continues until the target temperature is reached. It could be 80 degrees centigrade, it could be 100 degrees centigrade, it could be 60, depending on what has been pre-configured. So once the target water temperature has been reached, the home pilot now turns off. And then we now have, as you can see, surplus energy. So this surplus energy can effectively be fed into the grid if there is no further use for it. But mind you, as we're going to see in the coming slides, it will be better to make use of this surplus energy, because if we channel this to the grid, that is in a case where we're allowed to feed into the grid, once we want to buy it back, usually at nighttime, we buy it at a higher rate, because the feed-in tariff is usually lower, way lower than the energy tariff once we want to buy it back. So let's now take a look at the next example. So for this example, we see the same scenario of PV production curve, but then being utilized in a different way. So as you can see, every other thing is in place, but then we can see that there has been an addition of EV charging. So EV charging kicks in at power level of 3 kilowatts, which is the threshold for the EV charging. So this now kicks in after the power conditions or the set conditions have been met, accompanied with the charging of the battery and of course with the full pump operation. And then also we can see that the home pilot is also in operation after the full state of after the battery is fully charged. So we can see in this case that we have a fully utilized PV production. So it's better to increase the self-sufficiency by making use of the surplus energy generated, as you can see in this case. So like I said earlier, if you look at trying to go through or know the reason or the motivation to use PV power for heating, we could tell from the fact that 70 to 80% of feed-in powers are usually obtainable in residential systems, and then the feed-in tariffs are usually lower, way lower than the energy tariff. As you can see in this case from a survey between 2013 and 2017, we can see that the gap is ever widening, and by extrapolation, this is doesn't have any convergent point. It will only get wider. So because of this, it is essential to make use of surplus power as much as possible for personal use or for self-consumption. And then if we now ask the conditions where this would come in for economical value, it actually comes in very handy when we have lower feed-in tariff, high electricity prices, especially during peak periods, where regions or countries where we have feed-in limitations, just like David said earlier, with an example of Germany, and the cases where we use heavy appliances like boilers, heat pumps, infrared heating, air conditioners, and then of course countries with high temperatures and of course mild winter temperatures would find this application very useful and of great economical value. Good. So having said that, let's now take a look at how we can commission the GEN24 Plus inverter. I would want to say at this point that there are dedicated webinars for the different features and attributes of the GEN24 Plus inverter. So this webinar is basically to have a collection of all these attributes in one webinar to show you and to prove to you why it would be a wise decision to go for the GEN24 Plus inverter. So first off, in commissioning, we'd have to open the Wi-Fi access point of the inverter in order to commission it. And then this is done, of course, by pressing the touch-sensitive button at the middle, as you can see in this case. So this, just touching it once. So this, of course, opens the Wi-Fi access point of the inverter. Then, of course, this should be done after, of course, all the necessary installation procedures have been carried out, which includes all the cabling procedures, mounting of the datacom cover and the inverter cover, of course, and then of course turning on the inverter to position 1, because there are 2 positions. Position 0 means off, position 1 means on. So once that is done, you can now go ahead and open the Wi-Fi access point of the inverter. Good. I specifically mentioned it should be touched or pressed once, because 2 quick pushes opens the WPS function, and then 1 long push, specifically between 3 to 6 seconds, gives you access to service messages, and then of course, and vice versa by the time you repeat the same action. So 1 tap gives you access to the Wi-Fi access point, and then you can now go ahead with the commissioning. I would want to also say here at this point that this is just a summary of the commissioning process, and the commissioning process, of course, included in the picture perfect manual, always available, that comes along with the inverter. Okay, so, and then once the Wi-Fi access point has been opened, you have the option of doing the commissioning using your mobile device or PC. So for the mobile device, you can of course download the commissioning app, which is the Solar Start app. So with the Solar Start app, you can now, of course, go ahead and download the app with respect to the particular operating system. If it's an Android, you'd have to download the Android version. If it's iPhone you're using, you have to download the iOS version. So once the access point is open, there will be an automatic connection and then a step-by-step procedure on how to go about the commissioning. I will leave a link in case for those who would need the video reference. So there's a link, YouTube video on how to go about the commissioning of the Gen24 Plus inverter. So going ahead, you can of course do this, and then of course this using the web user interface. You can open that using a browser and then typing in this IP address. This is of course possible for every internet-ready device, be it a laptop, computer, or tablet. Good. So for installation via the browser, same process, opening the Wi-Fi access point, imputing the Fronius password, which is basically 1, 2, 3, up to 8. But then for Windows 10, there's a bit of a procedure that you'd have to take note of. And then, yeah, going through and then entering the IP address. Just to summarize it, there are basically 3 steps that you would need to go through during the commissioning. Once upon accessing the installation browser or the wizard, you would have to go through network connection, the product setup, and then the SolarWeb. So this means that first off, you'd have to connect the system to an available network. And then after that, you would now have to enter the product particulars, thereby setting up the product. And then once that is done, you can now bring the system to SolarWeb, which is our database. And then once the system has been brought to SolarWeb, it can now be accessed remotely. And then you can have a good view and monitoring access to your system. So same thing in this case, you can either do it via Wi-Fi connection or via wired or LAN connection, as you can see. But then in this case, the IP address to be entered is different from the one for the Wi-Fi connection, as you can see. And then it is advised that you use LAN 1 for such commissioning process. Good. So like I mentioned earlier, you would have to go through these 3 steps, but then each of the steps requires a particular password. So for the network, you'd need a customer password. For the product, you would need a technician password. Good. And then talking about passwords, it is necessary to have this password so as to regulate the operation or the access accessibility of certain settings per se. So for the guest, no login data is needed. And then, of course, assignment is possible at any time. You wouldn't have the possibility of doing any commissioning or on the inverter or on the network or the system. It will only be on observer mode. So you'll only be able to observe the system and whatever features you are allowed to access or view. And then for the customer settings, of course, you'd have a password assignment in the wizard, and then you would have access to certain configurations for this particular customer set password mode. And then we now have what we call the technician. So technician password mode. So for this case, this is usually available for the technician that eventually does the installation. So this is necessary so that they can make all the necessary configurations for the devices, the energy management, the system communication, and then we now have a restriction for this case because for the power grid, there are grid codes that are restricted even to the technician. So in order to have access to this particular code, you would have to contact Fronius tech support, and then of course sign an undertaking that you're absolutely sure of these settings you're about to make, because these are very sensitive settings, and if they are done wrongly, would definitely affect the performance of the inverter. Good. So once you're done with all the configuration and commissioning, you would arrive at a dashboard menu showing you the state of the inverter, and then you'd have all the necessary settings by the side for you to browse through. That is the menu settings. Like I said earlier, there's a link. This link here is active, so you can actually click on it to see how it's a link to a YouTube video to see how the commissioning of the Gen24 can be successfully done. Good. So after this is done, like I said earlier, the third process is, of course, to bring the system into SolarWeb. So this can be done either by the mobile, using a mobile device, or by, of course, going through the desktop version. So whichever way, it's basically the same process. So once this is done, you can either add it to an existing PV system, or you can now register it as a new system. Good. And then in terms of data communication, like I mentioned earlier, the pilot is the data communication device or medium of the Gen24 Plus inverter. So this makes it possible for the inverter to send data to our database, which is SolarWeb, of course, by the use of an internet medium. Good. So let's now talk about life cycle assessment. This webinar would not be complete if we don't give you details of the extent that Fronius goes to ensure that their products are actually environmental friendly. So the life cycle assessment is basically a sustainability assessment of the environmental impact of a particular product from the beginning or from inception till the end of its service life. So basically from cradle to grave. So there are so many instances, so many scenarios that were actually put in place. Lots of products, lots of Gen24 Plus were put through this LCA assessment. So we're just going to select one of the scenarios. So in this case, we selected for this particular webinar, we selected the case of the Simo Gen24 Plus 5 kilowatts operating over 20 years period using conventional modules and, of course, thermal waste treatment with subsequent metal recycling. I'll have to say here that the LCA is becoming a very, very important topic being discussed these days to, of course, understand the environmental impact that the production of a product, its usage, and of course, its recyclability. These impacts on the environment are actually becoming a very, very important talking point these days. So we have actually done our own part to do our LCA for Gen24 Plus inverters. And of course, this came out with very, very good results. To put it in perspective, would interest you to know that the inverter has 8% contribution in terms of carbon footprint in the PV system. So this means that without the inverter, the PV system has a CO2 backpack, we call it CO2 backpack of about 1,500 kilograms CO2 equivalent per kilowatt peak for system performance, which is usually written off over a period of 30 years of service life. So this automatically means that upon installation, it is the inverter that is majorly concerned or is saddled with the task of writing off this carbon backpack of the entire PV system. And of course, it does so even with the contribution of 8%, it of course comes in as a benefit to the climate because of the positive impact it has in the environment. So going into a bit of a detail, like I mentioned earlier, the LCA of the Gen24 Plus is, we have a dedicated webinar for this. And of course, you can access this or view this from our YouTube channel. We're also only going to give you a few details from this webinar just to give you much more reasons why you should go for the Gen24 Plus inverter. Good. So from sourcing, production, usage, and end of life, details were actually broken down in terms of the inverter, the Gen24 Plus inverter, in this case, 5 kilowatts, in terms of the electrical losses during the usage, transportation to customers, the production at site, transportation, components, composition, and then of course the waste recycling. So after all these assessments and investigations were done, it came to a calculation of a 405 kilogram CO2 equivalent. So putting it in a layman's term, and of course with strict reference to a very, very important point when it comes to recycling, it takes about 120, between 115 to 120 kilogram of a CO2 equivalent to have a new product. But then we are at this stage because we believe in recycling. So we now make use of 100% recyclate of the aluminium heat sink, as you can see. And then this, of course, is a very, very big achievement on the side of Fronius because we have the environment at heart and, of course, endeavor to make everything possible to have as less impact as possible on the environment. Good. So a summary of the results of this LCA assessment. Like I said, this is basically a summary of the LCA. Between 1,600 and 17,000 kilograms of CO2 equivalent are saved with the Gen24 Plus life cycle. So this is equivalent to about 7.5 times CO2 equivalent of outbound and return flights from Vienna to New York, which is quite substantial. The environmental benefits, of course, exceeds the impact by a factor of 5.3 to 26 times. Good. So, of course, and then the payback time of the climate impact of this product is in the range of 0.8 to 3.7 years. And this, I would say, is indeed a very, very remarkable result. For those that are interested, I shall leave a link for you to go through the full report that was conducted by the Fraunhofer Institute. Of course, they were the third party. This wasn't an in-house test. We had to have a certified third party oversight that had an official review and gave the certification for this particular investigation. Good. So for this, you have a link. This link is active. So if you want to have a full report on the life cycle analysis of the Fronius GEN24 Plus inverters, you can have this and then have a good look at it. We shall be sending out this report eventually after the presentation so that you can have a good look at it and then go through all the links that have been left for you in this presentation. Good. To end, we're just going to go through a brief live SolarWeb demo, just to kind of buttress a point about the efficacy of the Gen24. We shall go through a live system. Let me just track back to give you an overview of this particular system. Okay, so yeah, so this is the system as we speak. It's still in operation, so would go to a previous day. Let's just go to a previous day to have a wholesome view of the advantages that or how the Gen24 Plus operates, and of course, which is accustomed the advantages it comes with. So taking a leap from the previous day, that is 12 a.m., as you can see, the state of charge of the battery was 26%, flowing down up to the minimum state of charge, as you can see. And then about 6:30, at about 8 a.m. per se, we now started having a charge of the battery. That is when we started having a surplus with regards to the energy directly consumed by the load, as you can see. So the battery charge started, and then eventually at about 10 a.m. we reached full charge, as you can see, 100% state of charge. And then from then on, the rest of the power were directly consumed by the load until sundown, as you can see. And then we now started having discharge of the battery, full backup mode, of course, which is available for all Gen24 Plus inverters until it's slipped into the following day. So this is just basically showing you the operation of the Gen24, and of course with the advantage it comes with. If you take a very close look, you can see that let me put it on consumption mode. So that's when you now see the advantage of the system. If you look closely, you can see that the power taken from the grid is really minimal, with the power being consumed directly from the PV, as you can see. So we have a mere 84 watts, 24 watts, as you can see, being consumed directly from the grid. So eventually, you only end up paying for the grid when there is no sunlight, and of course, when your battery is completely down. Great. So, of course, like I said, that was just a brief live demo of what is obtainable with the Gen24 Plus inverters, and of course, the advantage that comes with it. So for further information, you can, of course, visit our homepage, and then where you can get all operating and installation instructions. You can, of course, get how to installation videos, and of course, most importantly, you can get our webinar recordings. All the webinars that we have run so far, you can get them on our Sub-Saharan Africa playlist using this link. Once you click on it, to take you to our homepage. There you can now have a choice of whatever webinar you want to go through, depending on the topic of interest. Good. So for further information, please feel free to contact us using these contact information as seen. If you want to get directly to us, please ensure that you do so with respect to the technical sales advisor responsible for your region, Byron Kotza for the Southern Africa region, myself, Cyprian Okolo for the Western Africa region, and then of course, David Mwangi for the Eastern Africa region. So with this, we have come to the end of today's webinar. We do hope you enjoyed the presentation. Like as promised earlier, we shall be sending out this presentation to all attendees so that you can have a review of it, and of course, hoping that you enjoyed the content that we had for you today. So until we come your way next time, do enjoy yourselves and have a pleasant time. Thank you.